Hi guys, so that's a very simple demo for those who missed the class, just to show you how to find the center of mass of an object that is not shaped in a very symmetric way. So the center of mass is the point where everything happens, like all the mass is at that point here, and gravity is going to pull down, okay, on that center of mass. So here I have a lead line here. So gravity is pulling it down. You have a tension. So I'm gonna put that here. And it's something you can do at home. You can just take a piece of cardboard. You need something heavy here. So that what it means, I don't know if you can see very well, but it means that the center of mass is on that line here, okay? Because gravity is acting on that center of mass. So if I take a marker here, I know that the center of mass should be somewhere here. It's hard not to shake. So it should be on that line here. Okay? So now what you can do, you keep that line here, and I'm gonna hang it here at that corner there. So that means that the center of mass is again somewhere along that line. So the intersection here is the center of mass. So I can make a line here. Okay, you can do better than me, I'm just shaking. And you can verify if you take yet another corner here, it should meet at that point there. So it's about there, right? So they are meeting, the three lines are meeting at that point. So if it's really the center of mass, I should be able to take that shape here and see if I put my finger there, we see it's in equilibrium. Center of mass is very important in physics because the center of mass will only respond to the outside force, right? So a lot of computation is done to simplify problems in the frame of reference of the center of mass. So I can take another shape. I have one which is interesting here. It's just a sphere. Of course, you know exactly where the center of mass is going to be. So we suppose we have objects that are homogeneous. You see the center of mass should be on that along that line that you expect because it's a diameter, and you can make a line here. So if I move it here, of course, the center of mass will be at the center of the circle, right? That you expected. So I can make a pause here. And you see that if I hold here, if I put my finger, it should be in equilibrium. You can have more interesting shape. Like, so here I have another shape, weird geometric shape here. And we're going to do the same thing. I have my leg line here. You see that the center of mass has to be along that line. So gravity is pulling down here. So I can take a marker and can try to make a line. So the center of mass is somewhere along that line. Now I can use another corner here. And again, I put my straight line that is showing straight to the center of the earth. And then I can make again a straight kind of line here. You see, they meet at that point here. That's where the center of mass is. I can yet use another formula, this formula there, and again, you see it's gonna meet here. So at that intersection, that's where the center of mass is. And again, if I take my shape and I put my finger there, you see it's gonna be in equilibrium. So everything happens like all the mass of that shape here is just at that point where gravity is pulling it down. Now I can take another shape that this one is, I don't even need a lathe because I know that the center of mass will be along the diagonal. So it will be, if I have my line here, you see, it's going to be scribed, it's going to be along the diagonal, just right, just there. Don't know if you can see. So, of course, the center of mass will be at the center here of the perfect square, right there. I can have a rotation about the center of mass. Okay, so center of mass is very important in physics because, for example, if you compute the momentum, if you have a system in the frame of reference of the center of mass, all the momentum, the total momentum will be zero. So it's a very important concept in physics.